You know, physics can be really annoying sometimes, especially when you're trying to move a lot of data.
Yeah, I mean, physics is usually non-negotiable.
Right. But here is the scenario for you. You have a pristine, uncompressed 4K video signal, and you need to get it to a screen that is 90 meters away.
So that's roughly 300 feet.
Exactly, 300 feet. So if you use a standard copper HDMI cable, what actually happens?
You get absolutely nothing, maybe some digital sparkles if you are lucky, but mostly just a black screen. Copper has resistance, and over that distance, the electrical signal it just dies before it gets there.
Which brings us to the topic of today's deep dive. We are looking at the Kramer CLS-AOCH series. It's a bit of alphabet soup, but the tech is what they call an active optical hybrid.
Right, and hybrid is the operative word here. This cable is essentially cheating the physics of long-distance transmission.
By changing the medium. And our mission today is to unpack exactly how that works. So let's look at the hybrid part. It's not just a fancy fiber optic cable, and it's not just copper, it's both.
It creates a dedicated lane for each type of job. See, fiber optics use light, not electricity, to transmit data. Light doesn't suffer from attenuation or signal loss the way electricity does.
So it takes that massive bandwidth requirement, like the 4K video at 60 frames per second, and
shoots it down 4 strands of OM3 glass fiber.
which totally explains how they hit those heavy specs in our sources. They mention 4.4.4 color sampling. To the uninitiated, that sounds like math, but in the video world, that's the holy grail, right?
It is. Most long-distance solutions compress the color information to save space. That's subsampling. But 4.4.4 means zero compression. Every single pixel gets its own unique color data.
And copper just chokes on that amount of data at 300 feet.
Totally chokes. But fiber doesn't even break a sweat. It can handle a data rate of up to 18 gigabits per second.
Okay, so if fiber is so superior, why is there copper in there at all? Why not go 100% glass?
Because your TV and your media player still need to shake hands.
The digital handshake.
Exactly. Protocols like EDID and HDCP, which basically stop piracy and negotiate resolutions. They require low-speed electrical data and actual power.
And glass obviously can't carry electricity.
Right, so Kramer runs copper wires alongside the fiber specifically for that communication. It allows for transparent ED and HDCP support.
That makes perfect sense. The glass does the heavy video lifting and the copper handles the logistics. Plus, using light for the video feed must help with interference.
Immensely. If you've ever run a cable through a ceiling in an office building, you're passing fluorescent lights, power conduits, maybe Wi-Fi routers. Copper acts like an antenna for electromagnetic noise.
EMI and RFI.
Yes, but fiber is immune to that. You could wrap this cable around a power line and the video would still be perfect.
Speaking of wrapping cables, the physical build here is surprisingly petite. For a 300-foot run, I picture a garden hose, but this is only 4.5 millimeters thick.
It is incredibly thin and lighter and way more flexible than standard copper options. But the real standout physical spec isn't the size, it's the jacket material. It's listed as LSHF.
Low smoke, halogen free.
This is a huge deal for safety compliance in building installations. Standard PVC cable jackets release halogens if they burn.
Which mix with moisture in the air to form hydrochloric acid gas.
Precisely. It is toxic and it destroys electronics. LSHF jackets don't do that. In many places, you legally can't install anything else.
It's a massive safety upgrade. Now, on the hardware side, the spec sheet mentions 24K gold-plated connectors, but there is also a mechanism called K-lock.
Yeah, ignore the gold.
Yeah.
The K-lock is the functional part. It's designed to prevent accidental disconnections, providing about 15 pounds of restraining force.
Which saves you from what they call the service call of shame, driving an hour just to push a loose HDMI plug back in.
Exactly.
Now we grab these details from HDTV Supply, who have a 25-year history with pro-grade gear.
Yeah.
The source even highlights a customer review thanking their VP Rachel Christian for great service.
Which is nice to see in this industry. It really is.
Yeah.
But let's talk value. The MSRP on this was $550, but the today's price is $440. Plus, they mentioned a coupon code 10% off. For a single cable that still feels steep.
You have to look at the alternative. Without this cable, getting a signal 300 feet requires transmitter boxes, receiver boxes, and power supplies for both.
Which introduces multiple points of failure.
Right. Suddenly $440 for a reliable plug-and-play solution that doesn't need external power looks like a bargain.
It effectively makes a 300-foot run feel like a 3-foot run. We really are seeing a shift from traditional heavy copper to lightweight interference-free fiber for long-range video.
As resolutions push past 4K, copper just cannot keep up with the physics.
So here's a thought to leave you with. With low smoke safety features and interference immunity becoming standard, are we reaching a point where copper HDMI cables become completely obsolete for anything other than short home desktop connections? Something to think about. Thanks for joining us on this deep dive.